back. Today we're going to talk about medians and altitudes of triangles. First, we're going to talk about the medians of a triangle. The median of a triangle is the segment from the vertex to the midpoint on the opposite side of the triangle. So you can see here that I've formed CD, and D is the midpoint of the opposite side. So it's a segment from a vertex to the midpoint of the opposite side. Okay, so how many midpoints, so how many medians do you think a triangle has? I've drawn in one of them. If you guess 3, then you are correct. So what I'm going to do is I'm going to label this over here, the midpoint, and I'm going to label a midpoint over here. And I know, of course, they're not necessarily the same size, and I'm going to draw these in. I'm going to try to draw them as straight as possible. No guarantees, though. Okay, so you're going to notice they all intersect at a certain point here. Okay, dropping down below here, finding the medians. I've labeled them up a little bit to try to help us, okay? And so what I'm going to do is I'm going to mark these sides congruent here because we know that each of these connects the midpoint. And they intersect at this point G. Well, what I'm going to say is point G, let me capitalize it so there's no confusion. And we're going to call point G is called the centroid. Okay, point G is called the centroid. It is the point of concurrency of the 3 medians. Point of concurrency of 3 medians. All right, and so I want to do a little bit of a demonstration moving into the next theorem to show you exactly what happens with these measurements. So let me pull that up. All right, so we're going to talk about medians and altitudes of triangles using a visual here. I've got this triangle ABC, and it's got this point L in the middle. Well, what I'm going to do is I'm going to go ahead and construct the midpoints of each of the sides. And you'll see that F, D, and E are the midpoints of each of the sides because each segment that is formed by that point is congruent. Okay, so I've got AD and DB congruent, EB, EC congruent, CF and FA congruent. Well, if I go ahead and connect the dots from the vertex to the opposite midpoint, these are going to be the medians. Now notice what happens. I've got all of them coming together, that point of concurrency at L. That's the centroid. I want to give you a visual on what's happening here. Okay, I'm going to expand this window a bit. And you're going to see I've outlined all of the measurements. So let's look at this first column. I've got AE, which is the length of the whole median, and then I've got AL and LE. Okay, so it basically goes the whole thing, the top part from the vertex, the bottom part. And I did the same thing for CD. I did CD the whole thing, then CL, then LD. All right, so then I've got BF, the whole thing, BL, and LF. Okay. And then I made some equations down here. I've got AL over LE, so it's, or AL over AE, so it's the top part from the vertex over the whole thing. Same thing for CL over CD and BL over BF. Okay, so that's my first line. And you'll notice that all those ratios are the same. I haven't moved the triangle yet. All those ratios are the same. So I have a 2/3 ratio of vertex to centroid over the length of the whole median. The bottom part is the same way. So LE, the bottom part over the whole segment, is 1/3. Then LF over BF, so the bottom part, meaning the part that's not from the vertex, over the whole median is 1/3. And then I've got LD over the whole thing, which is 1/3. So all of these measurements seem to jive. So I've got a 2/3 ratio from the vertex and a 1/3 ratio from the centroid. Now I'm going to start moving this around a little bit. Okay, first I'm going to pull on B. And you can see the measurements moving around. But I want you to take a look at the ratios. Okay, so the measurements have obviously changed. So when I do AL over AE, it's 4.30 over 6.45. Still a 2/3 ratio. What if I cross it over? Make it really, really small. Ratios stay the same. Ratios stay the same. Ratios stay the same. What if I exaggerate and I make it really big? Ratios are still staying the same. All of them are. What if I grabbed on point C? See the ratio staying the same? See how I'm moving it around? Crossing it over, still the same, okay? What if I pulled on point A? What do you think is going to happen? Everything stays the same. Folks, this is a theorem right here, okay? This is a theorem right here. Because if I start to move stuff, if I'm moving anything, I'm even grabbing on point D now. If I move anything, those ratios stay the same. That's our theorem. Let's take a look at it, okay? All right, so the centroid theorem says that we have these certain relationships that exist, and it's only going to talk about the 2/3, okay? So let's look at this, AP. AP is 2/3 of AY, okay? BP, so the vertex to the centroid, is 2/3 of BZ. And CP, C to the centroid, is 2/3 of CX. The key is go from the vertex to the opposite side. So it's 2/3 of the way from the vertex to the middle. All right, that's all there is to it. So let's solve a couple of problems to try to help us out in understanding this. In triangle LMN, RL is 21, SQ is 4. We want to find LS. Okay, well RL is 21. So that means that if we've got a centroid here, which is S, and we know that it is because the segments go from the vertex to the midpoint on the opposite side, that this is 2/3. This is 2/3. This is 2/3 of the segment that it's a part of. And so if I've got RL equals 21, then 2/3 of that is equal to LS. So that's 14. Okay? They didn't ask us about this, but SQ is 4 here, right? So that means this must be 1/3, so NQ would be 12. Okay, that's kind of how this works. This one kind of got cut off, but it's based on the same triangle. Okay, so let's look at it. Find NQ, that's what we were just talking about. So if NQ is 4, it's going to be 1/3 of, 1/3 of NQ is equal to SQ. Now, how did I know that? The part that goes from the vertex to the centroid is the 2/3 part. So that's going to be the top part here. Remember, it's the 2/3. I've got it labeled still. So 2/3 of the total distance is going to be NS. So SQ is going to be 1/3 of the total distance. So I'm going to say 3 times 4 equals 12. So NQ equals 12. All right? Moving down here, I would like for you to see if you can find this one. Okay, see if you can work on letter C by yourself and figure out what the distance is that is KW. One more thing, the orthocenter. The orthocenter is another one of these points that's found in a triangle that's formed by making a perpendicular segment from a vertex to the line containing the opposite side. Here's what it looks like. A to D is a perpendicular line. Not necessarily a bisector. Could be, not necessarily. And BE is a perpendicular line, not necessarily a bisector. And CF is also perpendicular, not necessarily a bisector. Where they intersect is the orthocenter. This is inside an acute triangle. Well, there's another case, an obtuse triangle. In an obtuse triangle, notice what happens here. A lot of things going on. This is where the line containing the opposite side comes in. Because if I look at AE, it's a side that's contained in this line that continues on this dotted line, all right? And so if I'm taking a line from B to AE, so it's the opposite side, I can't get there. If I go to any of these spots here, it's not going to be a 90-degree angle. So I have to come all the way out here to get my 90-degree angle. And it's the line containing that opposite side. And if I continue that line, it's going to come to this point here. All right? Same thing here. If I go from E to AB, this is a 90-degree angle. Well, obviously, it's not going to intersect that line that I just made here unless I continue it. So it continues down here. And also, from A to intersect BE, none of these lines would be a 90-degree angle, right? So I'd have to come way out here to get to a 90-degree angle. And this line contains BE. And so they're going to intersect outside the triangle for the orthocenter. We're going to practice this stuff in class, but that's the basics of medians, centroids, orthocenters. Keep that in mind. We'll see you next time.